Please. So our objective today is that we're going to differentiate properties of metals and nonmetals. Yesterday we took some notes over metals and nonmetals. Now we're going to take it a little step further, or basically just look at it a little bit more detail on the different properties that they have. So by the end of this period, you should understand the properties pretty well, okay? And you should be able to answer the essential question, which states, when would you want to use an object made of metal in your everyday life, and would you want to use a non-metal? So, thinking about things that you do in your everyday life, okay, let's say cooking. You can grab a hot pan. Think about it. Would you want that object that you're using to grab the hot pan with, would you want it to be made out of a metal element or a non-metal element? A non-metal. Why a non-metal? It doesn't heat up as much because it's an insulator or a bad conductor of heat, right? So those are the things that I want you to look at today. So everybody should look at the paper that I gave you, which is the purple paper. It says metals and non-metals comparison and the periodic table. So this is your activity for today. So I'm going to go through and explain each and every step. Each of you is going to make your own comparison table, but you want to create it and make sure that it's correct by talking to the other people, to your partner, to your table partner. Okay? So, if you look at one, it says, with your partner, look at the objects given to you and decide which will demonstrate conductivity of heat and electricity, malleability, inductibility, insulation, okay, brittleness, luster, dullness. So, when I let you go, you will basically get the following things. You're going to get wire, you're going to get a toothpick, piece of plastic, aluminum foil, and then on your tables you should have a brown marker. Okay? So you're going to look at these objects and you're going to think about the properties of metals and non-metals. So you're going to think about this plastic, and you're going to think about the properties. And figure out, okay, so is this going to be representing a metal or non-metal? What do you think? This piece of plastic, think it represents a metal or a non-metal? Non-metal. Okay, so, and you're correct. But in your group, you're going to discuss why you think it's a non-metal. Okay? So you're going to go through and talk about each of the objects that I give you. And then you go to the next step. Within your group, decide which properties are metals, metal properties, and non-metal properties from the property list. So the other piece of paper that I gave you was that little green sheet that says property list. So out of these, you're going to decide which ones are metal properties, which ones are non-metal properties. Always go back to your notes if you can't remember. Okay? Then 3, trace the notebook page around the unfilled periodic table and cut it so it'll fit in your notebook. I already told you to do that, so you should already have that done. 4, label the left side metals and the right side non-metals. Why? Why the left side is metals?
Because metal's on the left side.
Because that metal's on the left side of that zigzag line, right? And then non-metals on the right. So, we're talking about metals and non-metals, so who are we ignoring today? Metalloids. Okay, so we're going to ignore the metalloids. Yes, they're on the periodic table, but we're going to ignore them today because what do we know about the properties of metalloids, Jesus?
They're different. They can be same from metals and non-metals, but you don't know the properties which you have.
Okay, very good. So since you don't know until they bond, we're going to ignore them today. Because all we're looking at by themselves, what properties do they have? So metals and non-metals are the only ones that have that. Alright, so you're going to do that. So you're going to color blue and yellow. So your periodic table should end up looking like this first. Blue and yellow. Why did I color this top part yellow? Because that's a non-metal, that's hydrogen, right? Okay, so this is what that should look like. Do not start coloring right now, because that's step 5 and you haven't done step 1 or 2. Or 3 or 4. Alright, 6. For the properties of conductivity of heat, electricity, insulation, malleability, ductility, brittleness, luster, and dullness, write your words on the side that belong. So, you and your partner should have decided conductor of heat, if that's metal or non-metal. If it is metal, then you're going to write it over here on metal. This is why I told you wanted that white part, so it'd be easy for you to write on here. Okay, so you're going to put conductor of heat. If you think that's non-metal, you're going to write it over here, conductor of heat. So wherever you think it goes, you write it down. Okay? You're going to do that for all of them. Then you're going to take your examples representing those properties across the periodic table. So, conductor of heat, conductor of electricity. Where do these go? Metal. So I'm going to write these right here. Conductor of heat, conductor of electricity. Now, would this wire be a good representation of a good conductor of heat and electricity?
Yeah.
Yes. So what I'm going to do is I'm going to take this wire and I'm going to tape it right beside those words. So tape your object to which words are representing that object. Okay? Yes?
So we write the words in the periodic table?
Yeah, you're going to write them right here on the side. That's why I told you not to write around, because this way you have these objects right here and you can see the words to the side. Now, you can do them in here if you want, but make sure that whatever you choose to write with, it stands out from the color that you put behind it. That's why I always like doing it in white, just because it's easy to see and I don't have a different color mixing with it. Okay? But it's up to you. It's your periodic table. Alright, so I should see your words and I should see your examples taped in there. Now, for the property of melting point, you're going to write your words on the side that they belong. So once again, if it's high melting, low melting, whatever you think it belongs, I would do this all the way at the bottom. And you're gonna write your words and you're going to make a color grid. A color grid basically just means a long box with colors. So you're having high melting point and low melting point. What colors do you think you should use? Red and blue. Now, you decide which color you want to use, but let me just tell you this one thing, especially because it's something towards what we're going to work with when we get to the universe. What you think of really hot is the opposite of what it really is in real life. Okay? Which color do you think is the hottest? Red. You think it's red, right? Because think about it. When you ever turn on the water, isn't the red one the hot water and the blue one the cold water?
Yeah.
Guess what?
Blue's actually
Blue is actually the hottest color. Okay? That's why blue stars are hotter than red stars. Think of, have anybody you ever seen a welder's torch?
Yes.
A welder's torch has a blue flame because it's so hot that it melts metal.
Oh, the thing that it has one side.
If you've ever seen a fire, have you ever seen fire that it looks kind of bluish right in the center and it goes into orange?
Yeah.
Right the center is where it's the hottest. Your blue is actually hotter than your reds. Okay, excuse me. Okay. Well, because I always sound like I need a pass. Yeah. Okay. Yeah, I'll change it then. Okay, so, focus. So you're going to want to put the red on the highest melting point. point, and the blue on the lowest melting point. But if you really think of scientifically, blue is the highest melting point, red is the coolest melting point. It's still hot. I'm telling you, it's not hot. But it's cooler than the blue. Okay?
How come in the sinks they put that?
I guess just because whenever
Because blue looks like
people started looking at the colors, blue kind of looks more mellow, and I don't know. I mean, but scientifically, it's actually the other way around.
I read a book about the universe and it has the different stars with the different colors of how hot it gets.
Mhm.
And then it has the white, which is like the
Blue, white.
dwarf, and then it goes to higher.
Yeah.
And it ends up with being blue as the hottest.
Yeah. Your blue-white stars are the hotter stars. Your red stars are your cooler stars. Now, once again, it's still hot, but it's cooler than the other ones. I'm sorry?
Yeah, red stars.
Yes, but then, you can't see it. You look at wavelengths, and when we get to the universe, we will talk.
Oh, that's not we are going to
I'm trying to find that book.
The sun is actually middle temperature.
Like yellow.
Okay, so let's focus. So when you make this color grid, okay, it is your color grid. So if you're going to be able to remember this, and you want to do it correctly, the scientifically correct way to do it, then your blue would be over here because metals have the highest melting point, right? Your red would be over here because they have the coolest melting point. Now, that is if you want to start learning that, because you're going to have to know that when we get to universe. But if that's going to confuse you, okay, if that's going to confuse you and you're going to mess up on the test, then by all means do red and blue. But I want to give you that so you can start thinking about that, because you're going to have to know that for the universe, and you're going to have to eventually switch your thinking. So I figure, let me go ahead and give it to you now, and you can start switching that thinking now. Okay?
So we just like color.
Yeah, basically what I would do is I would take a marker, and I would do blue, and then I would do red, and then right in the center, once blue and red mixed together, make purple. So I would kind of start changing it from blue to purple to red. It's just so you can see that it changes gradually. Okay? Once you do that, you draw arrows from left to right and right to left, and tell me where it's increasing and decreasing. Okay? And then after you do that, this is stapled into your note. Staple it, don't tape it. If you tape it, it's going to fall off because it's a little heavy. Any questions on what we're doing and how we're doing this? All right, so I'm going to pass out the equipment. While I'm doing that, my suggestion is that you and your partner start looking at this and start deciding which of these are metal and which of these are non-metal while I pass out the equipment. I'd rather you not, because it's a class. Unless you write really, really light and you erase it.